Alright people, welcome to another session of Boo at Solidworks. Today we're going to draw a Harpic bottle. So you know what I mean. We're going to draw something which has three parts to its blueprint. One page here. This is another one. Second page is here and the third page is here. So first of all, they're going to ask us to draw a curve through points XYZ or XYZ, whatever you prefer. So these two curves, you're going to have to input these values in. So this is how you're going to do it. Curve through XYZ points, and then just this is painstaking, and I haven't found any easier way to do it other than this. You have to double click on every button, punch the numbers in, and then move on to the next slot, double click there again, punch that in, press enter, and then again double click, punch it, physically punch them all in, and that's how you move on. So it's a tedious and boring job. I'm not going to do it on record. I've done it previously, and I'm just going to input the curves right now. So curve XYZ, browse, and so where did I keep them? Oh no. So they're here, and select this one, and okay, click OK, and then again side curve, select this one, and that's done. So yeah, the hard part the actually very boring and hard part, we just got through that. Okay, now we have to basically this is going to be this is going to be a sweep. So let's start doing that. Now in order for a sweep, we know that we need a profile and a path. So what we have right now are the two guide curves, this one and this one. These two are the guide curves, and now we're going to generate the profile and the path. So now we're drawing on the top plane. I'll make it visible. Now I have to draw an ellipse as the profile. So just draw a random ellipse, and so this is the hard part. Remember to do this exactly as I do right now. First, control select this curve, okay, and then control select this point, and then go pierce. If you try to do this any other way, it won't work, I swear to God. Okay, see that worked. Now do it again for this curve, control select this one and then this point. So do it any other way and it's not gonna work. So control select this one, this point, and pierce. Okay, so that's done. So now we have our profile and our guide curves. All that remains is the path. Okay, so let's do that. And yeah, it can be either on the front plane or the right plane, it doesn't matter. So normal to sketch. Okay, now just select that point and draw it like that. And yeah, since it's going to be a path, I prefer it to be a construction line. Okay, so let's sweep away. Solidworks, you're wrong. Open sketch is never a path. Okay, so this is what we're looking for. And this, I did it wrong right now. Okay, so this is going to be our profile, and our path is going to be this one. So I wanted to select select open loop. Okay, select open loop. Okay, there seems to be a problem. So we faced a problem, and the problem was that I apparently was wrong. In order to create a swept boss or a sweep, you need to have both the profile and the path as a solid line. You cannot have it as a center line. So yeah, I fixed that problem. I changed the path from a construction line to a solid line, and now hopefully we can sweep it. So we choose the profile, choose the path, okay, and it's done. And our guide curves are these two XYZ curves, and we selected them, and now we're done. Okay, so now we get to the hard part. We have to oh no, we're not there yet. So now we have to draw. It says on the blueprint here, says on the blueprint, yeah, 15.88 millimeter neck extrusion. So this is what we're gonna do. Convert this and extrude it 15.88. So there, we're done. Now what does it say? It says 6.35 millimeter and 9.53 millimeter variable radius fillet at the bottom. Now this is one, yeah, this too seems to me like one of the challenging parts of this drawing. So in order to you've done constant radius fillet before, you've never done various radius fillet before, so pay attention. So just, yeah, I'm gonna choose a sketch. Okay, oh no, I'm not going to choose a sketch. Okay, just select this face and click fillet, and so you see you have constant radius, variable radius. Just click variable radius. Okay, now items to fillet. Just select this edge, okay, and it automatically selects P1, that is this highlighted blue point for you. Okay, so now you have to assign what fillet, so now you have to assign a fillet dimension to this point right here, and see, and the orange points are unassigned. Okay, so now it says 6.35 and 9.53. so this is what I'm gonna do. You're at liberty to do this. Since this is the major axis of the ellipse, I'm going to assign the larger fillet here. Okay, and since this is the minor axis, I'm going to assign the smaller fillet here. So this is going to be, so this point is already selected. Oh, okay, so this point is already selected. It's highlighted blue and the others are orange, so it's already selected. So you just click here once, and you see, erase that and punch in 9.53 and then enter. So now it's assigned. Now select this point and follow the same procedure, but this time we're going to go with 6.35. So you see, now it shows you a template of what it's about to do. So at this point you don't need to specify the further 2 points, because from a sense of symmetry, Solidworks worked it out. So just click set unassigned. Okay, it's not working. No, this won't work. Oh, it did. So just click set unassigned and voila, it's done. So I'm as uncertain as you are as to what's about to happen. Okay, now let's get to the shelling. We need to, so if we cut through this bottle, this is what we're going to get right now. See, it's solid, but it needs to be hollow inside. So we get to the shelling now. And what are our instructions? Shell with 1.5 thickness at the neck and 0.5 thickness everywhere else. So this also you're not familiar with. It's a variable shelling option, and it's not like the regular shelling option. So let's try it out. See, in this case you have to use this multi-thickness setting. So it says 1.5 at the neck and 0.5 everywhere else. So let's so since it's going to be 0.5 throughout the whole body, so we're going to punch in right over here 0.5. There you go. And multi-thickness settings. So see, multi-thickness faces, and can you guess which face requires the multi-face a multi-thickness setting? Yeah, you guessed it, it's the neck. Oh, come on, please, wrong selection. So I click here first, see here, and then I click here. Okay, so this one is going to be 1.5, and hopefully this will work. Yeah, see, it did. So what's the proof that it worked? We click this section view here, and it shows us. So see, 1.5 here, so this is thicker, and 0.5 here, so this is thinner, and it's a hollow bottle. So voila, that's done. Okay, now we're gradually nearing the really difficult part. So now we have to we have to make a thread around this neck extrusion so that we can screw on a cap to this bottle. Okay, so let's get to that part. Now this is going to be the most difficult part, and I warn you people. Okay, so this is the blueprint for the thread profile that we're going to draw. So remember, back when I taught you how to sweep, I told you that I taught you two terms. One is a profile and one is a path. So this is going to be the profile, and the path is going to be a helix, because we're going to generate a thread right now. So not all threads are circular shaped or square shaped. Some may be shaped like this. So this is the profile of our thread, and now we have to draw it. Okay, so let's get to making the thread. So first we select this face, and then we click sketch. Okay, we're already in a sketch. Okay, so sketch, and then convert entities. Automatically it selects the outer circle and converts outer edge and converts it into a sketch, and then helix and spiral as specified in the blueprint. Pitch has to be 3.81, revolution has to be 0.5, and this angle is usually never 0 degrees, so make sure to make this 0. There is some merit to doing this, and I'll explain that later on. Sometimes what happens is you don't get the helix in the way you want. Yeah, that's usually the way you get it. So remember to click this if you want it the other way around. That is the reverse direction checkbox. Okay, so we're done. So now that we've generated the path for the thread, let's draw the profile. So we can draw it either on the right plane or the front plane. But yeah, see, this is where our path ends. So I guess, okay, so yeah, no, you cannot draw it on the front plane. Yeah, so the profile must be perpendicular to the path, and in order for that to happen, we need to either change the angle of the helix, or draw the profile on a different plane. So I'm going to just draw it on the right plane. Yep, let's draw it here, and let's click normal to once more. Okay, let's because look, here I have to draw the thread in as a mirror version of this. So instead I'm just switching to the other side. Yeah, so yeah. Oh, they confuse me. Oh my god, what's happening? Okay, yeah, I finally escaped the vicious circle of confusion. So this is what happens. See, this is how they gave your blueprint. So you always have to draw it like this, or you have to mirror it. So if you want to avoid the hassle of mirroring it, just make sure that you're drawing from the right angle. So yeah, if I draw it here, I don't have to mirror it. Then I just have to pierce the center of the profile with this point here. And I had problems finding this right angle, and here is how I solved that. So initially when I clicked on right plane, it gave me this direction. So just before you select the right plane for sketch, just click normal to, and you can flip around. So when you've got the angle, then select it for sketch. Okay, so now I've got my angle. Now I'm going to sketch it. So I want to make this visible, yeah, for obvious reasons, and I'm going to make this screen a tad bit smaller. so that I can see the blueprint and design at the same time. So yeah, let's get to drawing it. First I'm gonna draw this line here. This is crucial. So okay, how about not center line for construction? Okay, yeah, it's the same thing basically. It's the same thing, center line, construction line. So yeah, it's a vertical straight line, and I want it to be, see, 2.03 millimeters long. Okay, fine. And then I want to draw this line, but this can be indefinitely long. So I'm gonna select it to have infinite length. Okay. Now we're gonna draw this line over here. So just draw a random vertical line and dimension it so that it's 0.76 millimeters away from this line here. And the other line, should I draw this line right now? No, I don't want. I don't feel like doing it. Should I? No, I'm not gonna do it. I'm gonna draw these lines here. As you can see, they are dimensioned to be 30 degrees and 5 degrees with the horizontal center line here. So two lines, this one and this one, at 30 and 5 degrees. Let's do that. And they're gonna pass through this point here. So I'm gonna make them long enough. Coincident, so it passes through the point, yeah. And the other line, coincident as well. Now we assign the angles. So smart dimension, click this, no need to control or shift click. Normal clicks will do. 30 degrees, and this one and this one's gonna be 5 degrees. So yeah, we're done. Now I'm gonna draw this line, this line over here. Just drawing a random line, and later we dimension it so that it's 1.02 millimeters away from the center line, the vertical center line. Okay, I think we did a pretty good job there. Now we're gonna fillet these two places, and then we're gonna trim the rest. So fillet. Okay, there's no point here, so I can select that point for a direct fillet. So I'm gonna have to select these two lines. Okay, we're done. Yep, we're done. So go back to full screen and trim out all the unnecessary items. Okay, yeah, I think we're done. Yeah. So now the important thing is, what the hell did I just do? Okay, don't want it to be for construction. Okay, I want this to be an actual line, so how about I trim these two out? Didn't want that to happen. Okay, how about this is gonna cause a major problem. Okay, I'm gonna solve it and get back to you guys. Okay, okay, so it didn't cause a major problem. I want to generate a point here, and my thinking was that because both these lines are center lines, a point could not be generated here, but that can easily be solved by just cutting off one part. So now, yeah, we have a point here. So now our challenge is to make this pass through this in a completely normal, that is perpendicular fashion. So just, so initially this is what you think you'll have to do. So yeah, just choose this point, choose this point. Okay, can I choose the point? Choose the point, choose the point. Okay, go on. Exit the trim. Yeah. Oh, I did like that. Okay. So just, I'm gonna select this point, right? And then I'm gonna select this curve. Then I'm gonna say pierce, right? Look. Oh, it worked. Nice. I have no idea how that worked. It will not work most of the time. Here's what you'll have to do if you want it to work all the time. Okay. So that method is not a guaranteed success, let me tell you that, guys. Most of the time what will happen is you select this point and you know, select this one, and then you say pierce. So what happens is just this middle center line and this point transfers over here, and it leaves the rest of the solid lines over here. In order to avoid that, this is what you have to do. Just, you know, drag your mouse and select the whole sketch, and right over here block, and then when you click this button, I'm not clicking it now because I've already clicked it once. When you click this button, this new tab will appear to your side, and then all you have to do is click this button. Okay, and it asks you to make a block, then you just click the tick mark. Okay, then this is what you do. See, you have not exited the sketch yet, so you can select points and do whatever you want even now, although you know it may appear a little, you know, discolored. So just select this point, no, okay, so select this point and this one, and go ahead and pierce. This is a rather strange incident. Alright, so yeah, there's a very easy way to solve that problem. Just, you know, while you're still in the sketch, just select this line and click vertical, and voila, you're done. So I'll explain right now what I did with the block feature. It makes, well, so once you select a group of entities and click here and create a block, you make their relative positions fixed. That is, their positions with respect to one another will not change. So that's what basically making a block is. So now we're done, so let's just draw our thread, the most awaited moment of the year, drawing the thread. So let's sweep it. As you can see, we have encountered a problem here, and I'll tell you why. In our blueprint, it was written over here, draw a helix 2.5 millimeters from the top. So what I did was I selected this edge right here and drew the helix from there. So I was supposed to draw a helix 2.5 millimeters below the position where it is right now. So I don't think that's a big deal, do you? Let's fix that. So here's how you do it. You just select this plane here, and we need another plane parallel to it at a distance of 2.5 millimeters, and it's obviously going to be below, so you have to reverse it. That is, click this flip over here. So voila, that's done. Now just select this circle. Remember, we already converted that circle, but if you don't want to go into that mess, okay, just select that one, and you know, now just select this plane, sketch on it, select this circle and convert it. Didn't want to do that. Okay, select this edge. So basically the circle we converted earlier was, giving us the problem. Now it won't give us a problem because I deleted it, and I'm going to select this edge. Okay, I forgot to select sketch. Okay, select the plane and sketch, select this edge and convert it. Oh, what? Again? So I was wrong again apparently. Too many roadblocks. Okay. Okay. So first select this plane for a sketch. This one. Then convert entities and create this circle. Then select that plane 2.5 millimeters below. Select that for sketch. Then select that circle again and then convert it. So okay. So right now what's happening is you're learning about all the mistakes you could possibly ever make while doing this drawing. It's good and bad at the same time. Okay, so let's generate the helix right now. Yeah, so we punched those in before. That's done. Now we have to edit this sketch a little. Okay. So yeah guys, I'm back, and so I did the thread, and okay, here is our profile. Select the center point, select this, pierce it. Okay, again, come on man. Okay, I'm just gonna select this and make it vertical. That solves the problem. And sweep it. This is our profile, this is our path, and it's done. Also see here that they ask us to round off the thread endings. So we have to, it's basically very easy. Just select this plane here, then convert it, and then exit sketch, revolve base, select this line, and voila, there you go, you have it. Do the same for this, sketch, convert, revolve, select this line, and that's done too. Okay, now all you have to do is draw a portion for the label. And let me warn you here, there's a warning to be made. Always draw the thread profile after you draw the helix, because if you do not do that, then you cannot select Okay, let me show you directly. Show this sketch, right? So what did we do? We selected this point over here, and then we selected the helix, and then we set a pierce relation. But when can you select this point and assign a particular relation to it? When you're editing this sketch, you cannot assign relations to this point at any time other than the time when you're editing it. So, and remember, when you start editing a sketch, all that you drew after disappears. So when I'm gonna click edit sketch, see that sweep, it disappeared because that was something that I did after I drew this sketch. So red light warning over here. Always draw your thread path after you draw your thread profile. Okay, so now we have to draw that thing for the label. So front plane, normal to front plane. So yeah, we're gonna sketch on the front plane now. And what are we gonna sketch? This thing right here. And let me tell you something, this diagram, it's not gonna be the same for everyone. Because you see, they do not specify a very important dimension here. This one, what's the length from here to here? They do not specify it. Or maybe some of you may have deciphered it. There's something in this diagram that I can't read, but you can. Maybe some of you have done it, but certainly I don't see anything that specifies this distance from here to here. So I'm gonna just take the liberty to do some things on my own, and I hope you do the same and don't get too worried about it, because I believe that this diagram is not going to be the same for any two people unless you copy your friend's one, that is. Okay, so let's just get to doing it. Here I'm going to teach you an option that I learned from one of my friends, Arafat. It's called dynamic mirroring, and this is the best. So here it is, but you can also find it symmetry check. Okay, apparently you can't find it. Okay, just type that in, dynamic mirror entities, just click that one. Now it asks you to select a sketch line about which you'd like to mirror everything you draw. So first I'm gonna draw a center line, and then I'm gonna select dynamic mirror entities. Wait, something happened here that I am not getting. So you've got to make sure that you're not inside a sketch when you're selecting this dynamic mirror function. So I've exited the sketch. What? No, I think I'm. So I get back to sketching. I'm gonna draw for construction line. Okay, and then I'm gonna write dynamic mirroring here. Dynamic mirror entities. Okay, now it asks me to select the line, so I'm selecting this line. So I've selected that line, and now everything I draw on this side of the line will automatically be mirrored on the other side. So now, as I told you, this is no accurate profile, and no two people will have the same profile. So just use your instincts and draw what is right according to your whatever feels right as per the bare naked eye, as per your bare naked eye. I'm getting a little vulgar here. Okay, so now I think it's alright, matches it pretty much. Okay, now we have to draw two fillets over here. So for that, you select the tangent arc. Okay, so a tangent arc, and draw it so that your arc does not loop inside like that, and it doesn't loop like to 90 degrees either. See, so you can see 90 degrees is written. You don't want that happening either, just so that it points outward. Make sure that it points outward. Okay, and this is going to be assigned, so start dimensioning right now. So 12.79, yeah, well, we got pretty close. See, it has to be 12.7. The other thing that we have to take care of is, look, this dimension here, dimension whatever, 12.7. so select center point, this point, 12.7. okay, now you draw another arc, and it has to have the radius 114.3. so let's do that, and make sure that this time it points inwards, and also make sure that its center lies somewhere over here, the center of the arc, because see, in this diagram, this is where the center lies. So try to just, match it as best you can with your naked eye. Whoa, what's happening? Okay, so you can see just to the top right corner of your pencil, it shows you what radius. So try to match it even before you smart dimension it. Try to match it with the original blueprint. That helps a lot. Okay, I guess I'm pretty close. I'm going to leave it right there. Now I'm going to dimension it. So 114.3 as it says in the blueprint. Okay, I think it's a pretty close resemblance, this and this. Now for the final arc, which has a dimension of 25.4. So I'm going to do this, and it says unable to create symmetric element. No problem, overrule that. Okay, it doesn't have to be symmetric, it has to be 25.4. There you go. I think it's a pretty close resemblance, this and this. Yeah, what do you think? Oh, and there's one final dimensioning left. So see, this dimensioning, you're wondering here, okay, so this gap is 40.64, but I get it, it's 40.64, but at what height do I go? So I did a little bit of thinking, and you actually don't need the height. This is actually the maximum width of maximum distance between this line and this arc over here. The maximum distance has got to be 40.64, and for that reason you have to draw a dimension line which is a tangent to this arc and parallel to this. So here's what we do. We click this one, and then we press shift, we hold shift, and then we, yeah, so see, anywhere you go it shows the tangential distance 40.47, and we got really close. So I'm still holding shift right now. Okay, I click, I'm still holding shift, I release shift right now. Okay, now I click. So 40 point, what was it, 40.64. oh my god, I got really close. 40.64. okay, so see, the power of your instinct and the ability to match it with your naked eye, never underestimate that. We got pretty close just by making rough estimates. So that's done. That's that, it's done. Now we have got to project this curve onto these surfaces. So you know that Solidworks cannot draw on curved surfaces. In order for that to happen, what you need to do is you need to draw on a flat surface. In this case we drew on the right plane, and then you need to project it onto the curved surface. And how are you going to do that? Here's how. Okay, exit the sketch and select curves, project curve, and it's already selected this sketch for you, and you just have to select which curved surface you want to project it on. There's another thing called sketch on sketch, so we don't need that. We need sketch on face. So make sure this one is ticked, this one is selected. Okay, now obvious, this face, right? This is done. Now what we need to do is draw a circle that passes through this path. That circle is going to be the profile, and we're going to make another sweep. So where is that written? Okay, they're written over here. 3.18 millimeter circle profile sweep. So let's do that. So on which plane are we going to draw right now? Yeah, you guessed it, the right plane. It's going to be exactly perpendicular to our sketch. So we draw the circle, dimension it, select the midpoint, control select this. Okay, something's happening. Okay, I select this, control select this, pierce it, you're done, you're good to go. Sweep it. This is the path. Okay, so yeah, you're done. Now this part is an extra part that you can do for fun. I'm not recommending this for the night before the exam. You can just do it for your personal fun. I did it, so you can try it as well, and you'll end up with something like this. See? Now don't you tell me that this doesn't remind you of a Harpic bottle. In the lab they made you color this blue and red. I mean, what is out there other than Harpic which is colored in that way? So you can do this if you want to, but I'm sure it won't come in your exam or anything. So here's how you do it. If you want to attach a label here, select this, okay, then select decals, okay, then double click on any one of the symbols. Then what you do is browse a picture. Okay, you get the option to browse a picture over here. So here's what I did. I saved a picture of Harpic on the desktop, this one, and then so it lets you fiddle around with it. This is how you stretch it. So I stretched it, and okay, stretch it a little more, I guess. Okay, that's about enough, right? Yep, let's stretch a little more. Okay, enough. That's done. Now I'm going to color it. So I'm going to select this face, appearance. So if I select this, it's gonna color the whole body. If I select sweep, it's gonna color probably the thread. We swept that one. So I'm going to select face. So let's, there are lots of flavors of Harpic. Let's go for yellow. Okay, and in that case your thread and your bottleneck is gonna be green. So again, select face and select green, and for the sweep, so this time select sweep. Don't select face, because then it's gonna just color this or this. There are lots of individual faces here. So yeah, green again. And for the revolved features, revolve 2, green again. Revolve 1, green. And if you select this, you see there's an easier way to color. Double click and then keep selecting faces. That's done. Okay, I'm going to make this plane disappear. It's bugging me. Now I'm going to render. Let's see what render gives us. Oh, render integrated preview it's pretty good. So the graphics card on my PC is pretty good, which is why I'm able to do this. I don't recommend trying it on your laptop or your average PC because it might hang. So here you go, your lime flavored Harpic. Drink it if you will. If you die, it's not my fault. Adios, amigos.